Okay, the next part is line of best fit. So we are going to, for each of the following graphs, determine if the graph is linear or nonlinear. And if it is linear, draw the line of best fit. So a good line of best fit is one that follows a trend. So if it heads up, head up. If it heads down, heads down. And it's kind of in the middle in the data so that you have, because the lines aren't going to be perfect. And so you'll see this. You want to use a ruler and you want to draw a line so that there's the same number of points above and below. And we want to make sure that we extend the line to go from one end of the graph all the way to the other. So looking at A here, is this thing linear or nonlinear? It is clearly linear. It doesn't have a curve. Are there any points that I need to exclude, like any points of not discontinuity, but any, I forget what those points are called now, any outliers? So in A, there are no outliers, so we are going to want to draw a line with a ruler. And so I'm just going to put a line here. I'm going to start there and go. And it looks to me, if I can zoom in here, that my line goes through, wow, that's actually quite nice. It goes through all of the points. So that would be my line of best fit, though I do want to make sure I kind of go all the way to the end of the graph. So that's what I'll do. Now, for question number 2. Is this graph linear or nonlinear? So the first one was linear. The second one is clearly not linear. And so if it's not linear, we're going to make sure that we don't need to draw a line of best fit. That'll be something that'll be later on in grade 11. We'll look into those sort of questions. So now it gives us this one. Is this one linear? Now, if you did connect the dots and you're like, and you might see something like this, and you're like, that doesn't look like a line. But remember that data is almost never like A, where it's in a perfect line. So this I would still consider linear. It does look like it's going like that. So we're going to have to draw a line. And what we're going to try to do is draw a line that has the same number of points on top and on bottom. So let's see if I can draw that here. So there's my line. So I'll start it here, and I'll bring it down to here. So say I just left it like this, and you can see here that I've got 1, 2, 3, 4, 5, maybe 6 points that are above the line, and only this 1 point that's below. So I would say that's not a very good line of best fit. So I'm going to change this, and now take a look at this. So how many circles are completely, like this one's still touching the line here. So I see 1 and 2 that are above the line, and then 1 and 2 that are below the line. So that I would say is a really good line of best fit, though yours can vary slightly. And all the other dots, my red line is touching. So I'm looking to see which dots are not touching the line and make sure there's the same number above as there is below. So example, that was letter C. So I would say yes, that's linear. And then D, I would also say is linear. But again, if you connect the dots, it looks all wonky. But I would classify this as linear, and I'd classify this dot as an outlier. That in general, as the numbers go higher, 2, 4, 6, 8, 10, 12, our graph goes higher. But here at 4, it just shoots up to 70. And I don't know why. So that would be our outlier. And then the idea is, okay, we're now going to want to try and do a line of best fit as best we can. So I'm going to start, I'll try to start here, and then I will bring this up here, and I want to go to the end. And I want to count how many are above and how many are below. So I see this, I got 1, 2, 3, 4 that are below, and 1, 2, 3 that are above. So it's not quite perfect. And so now you can see I've got 1, 2, 3, 4 below, 1, 2, 3, 4 above. And remember, I've excluded this. So that to me is a good line of best fit. There's exactly the same number on top and on bottom of that line. And I think I'll just zoom out a little bit here so you can see the 4 that we've done so far. 3 linear, 1 nonlinear, and that very first one was a perfect one. So we're going to take a look at this. And this thing looks, it's all over the place. There's no way I can make a line here and say maybe all of these are outliers. If most of them are outliers, then it's not actually linear. So it is nonlinear, and it's not even a curve. It's just like a splatter of points. So there's nothing I can do with that. Then I have this, and is this linear? And what you would get is something that looks like this. This is actually an exponential function. It grows exponentially, which means it goes really, really fast. And it's also not a line. So I would classify this as nonlinear. And so we don't need to do a line of best fit for that. So I'll just zoom out here. So you can have a nice perfect, for B, this nice perfect curve like that, or you can have an exponential curve like an F, or you can have a splatter like E, but generally what we'll find is that C and D, where the data it looks mostly linear, there's sometimes an outlier, and you're going to have some points above and some points below.